Hello and welcome today. So right now we're going to look at how to figure out what are the conversion factors for that we're going to be using in chemistry, and it's really all centered around this very central concept in chemistry, and it's called the mole. Okay, now this mole is not the furry little critter that lives in the ground. Okay, it's not the thing that's on your face. This mole is a unit of measurement that was created by Amedeo Avogadro. And to put it simply, what he said is, if you look at carbon on the periodic table, you have a mass of 12.011. And we've learned that that's in atomic mass units. And what he discovered, or what he proposed, is that if I have 6.022 times 10 to the 23rd atoms of carbon, it will have a mass of 12.011 grams. Okay? So to really understand what, and this conversion can also be known as a mole. Okay? So this idea that if I have 12 grams of carbon, I have 6.022 times 10 to the 23rd atoms of carbon. It could also mean that I have 1 mole of carbon. So the easiest way to really kind of keep this straight in your mind is to do what I call the triangle method. And we're going to try to take a triangle. Let's see, a triangle. Okay. So we're going to take this triangle, and it's called the mole triangle. And it's just a simple way of remembering how these three different units, because it's the same quantity. If I have 12 grams of carbon in front of me, I have 12 grams of carbon. It's going to be a certain size. Okay. If I have that many grams of carbon, that means I also have that many atoms. It also means I have that many moles. So this is like three different units that are all connected together. So the easy way to remember it is the triangle. So I always put 1 mole at the top. So if I have 1 mole of carbon, then I also have 12.011 grams of carbon. Okay? If I have 12 grams of carbon, or 1 mole of carbon, then I also have 6.022 times 10 to the 23rd atoms of carbon. Okay? And we can almost put equal signs here. Okay? Well, we can't, not almost. We can put equal signs there. So just like 1 foot equals 12 inches, 1 mole of carbon equals 12 grams of carbon. 1 mole of carbon equals that many atoms of carbon. So now we have a system of 3 factors. Can anybody recognize what this is from earlier? This is what we called molar mass. And it was one of those I just said, well, just do it. Okay, well, we're going to learn about it later. Well, now it's later, and we're going to learn that molar mass, see the word mole in there, is the mass of 1 mole. Okay? Now, notice this, okay, so we're going to write 1 mole, we're going to write this number of atoms, and this is called Avogadro's number. Avogadro's number. You're going to write that 1,000,000 times. Okay? Avogadro's number is what that's called. It's a constant, it never changes. Okay? So the big challenge with the mole is figuring out what the molar mass is, which, if you remember, really isn't that difficult. But let's go ahead and let's check a couple. Let's try a couple and just kind of refresh our memory, but also kind of get a better sense of what this mole is all about. So 1 mole of table salt, NaCl. Now, on a side note, if you're wanting to abbreviate or shortcut the word mole, you can't write an M because that stands for mass. Okay? You got to write MOL. So the abbreviation for mole is you chop the E off and it's MOL. Okay? You got to use it like that because there's another M. There's actually 2 other M's that we're going to learn later on in some other units down the road, and it's going to get confusing. So moles is MOL. So 1 mole of sodium chloride, okay, equals, let's go ahead and put our equal sign, 6.022 times 10 to the 23rd. Now, carbon was just an atom, okay? What is this one going to be? Is it a molecule? Well, we haven't really covered this, but what kind of compound is it? Is it ionic or covalent? It's ionic, right? Metal to nonmetal. So that means that this is actually a formula unit. Okay? Because remember, this ionic compounds, what do? Do they share electrons or lose or gain electrons? What do? Ionic, lose or gain electrons. So they become magnets, right? So if I have sodium chloride, it's actually in a whole pile of these things where they're all connected together. But if I was to look at the ratio of particles in this, for every sodium I have, I would have 1 chlorine. Okay? So for every sodium I got to have a chlorine. So this one needs a partner, chlorine. So for every 1 sodium, I'm going to have a chlorine. That is the most basic unit. It's a ratio, and that's why it's called a formula unit. Okay. And that's because it's ionic. So ionic compounds, simply, it's always formula units here. What's this one? Now we just got to find the molar mass. So sodium, chlorine. How many atoms of sodium? 1. How many atoms of chlorine? 1. 22.999 and 35.45. Multiply those together and you should get 58. What is that? 58.44 or something like that. There's another number out here and I can't think of it right now. Okay? So you're going to get 58 and some change, and that's in grams NaCl. So let me rewrite this so that you know what I'm expecting you to write when you do this on your own. You should write 1 mole NaCl, triangle, 58 point, whatever the decimals are, grams NaCl. Notice that every time I'm putting NaCl. I don't do anything just because. There's a reason behind that, and you will learn what that is in coming units, okay? Please do not leave that off. Formula units. Okay? Alright, so let's do one that's covalent. Let's do H2O. So if I have 1 mole of H2O, okay, this is covalent, non-metal to non-metal, so this is going to be 6.022 times 10 to the 23rd molecules H2O. And what's the mass going to be? H, there's 2 of them, times 1.008, 2.016, and then oxygen 1 times 15.999. 15.999, and you add those together and you should get 18 point, let's see, 18.015. That's not right. 16, there's 16, okay, yeah. 18.0. Okay. What am I doing? $18.015. Okay, so it's 18.015 grams H2O. Okay, you got to write that. Got to write all of it. Okay. So, what's the rule? If it's covalent, it's molecules. If it's ionic, it's formula units. If it's an element by itself, it's going to be atoms. Okay? So here's a question for you. If I give you chlorine, which is an element by itself, what's the gotcha with that? Chlorine's formula is Cl2. So it's two of them bonded together, so this is going to be 6.0222 times 10 to the 23rd molecules. Okay? So be very careful about what you have. Otherwise, if it's, say, iron, it's going to be 6.022 times 10 to the 23rd atoms of iron. Okay? If I have 1 mole. Okay, so for your first round of this, I've given you a sheet with several compounds that you have to write that I've given you the formula for, and you're just going to find the molar mass and then fill in whether it's a formula units, whether it's molecules, and write Avogadro's number and practice that. So thank you very much. If you have any questions, please ask.